So hello everyone and very good afternoon. I hope you guys are doing good. So in today's session we will be solving questions of RCC which are important for your upcoming RRB JE examination as well as for your state PSC examination. Okay. I'll share this session so that so I hope audio video clear everyone. Is audio video clear? Okay, now we will start the session guys. Now in today's session we will be covering a few more questions of RCC. This lecture series will contain all the questions, all the concepts of RCC. Okay, and within a week we will be able to cover all the questions related to this subject. Okay, so our target is to finish all the concepts of we will cover all the concepts of RCC within a week. Okay, in this week. Clear everyone? So today I have taken the session at this time, but from tomorrow for rest of the days your class timing will be from 11 AM. Understood everyone? Just for today I have taken the class at 1:30, but from tomorrow onwards for the rest of the 5 days, okay, we will cover the session and we will start the session at 11 AM. Will it be okay? Please comment everyone. Will it be okay if I take the session at 11 AM? And trust me guys, very good questions are being taken in these sessions. Okay, you will definitely, most probably you will get the question directly from these sessions. Okay, so these sessions are designed in such a way that most probably you will get the questions from these sessions only. Understood everyone? So we will start the session. Okay, today's session, just for today, the session will be of will take around 20 questions, but from tomorrow onwards, okay, we will take the session such that we will cover more roughly around 50 to 60 questions in one session. Okay, so from tomorrow onward we will try to cover the questions such that we will be able to solve around 50 to 60 questions, and 2 hours dedicatedly we will cover the questions in 2 hours. Understood? So from tomorrow, that is, the date is 8th, from 8th of March, sorry, from 8th of April, your class timing will be from 11 AM. Understood everyone? 11 AM. Most probably we'll cover the class from 11 AM to 12:30 PM. Okay, so 1.5 hour class will take from tomorrow onward. Okay, understood everyone? So we will start the session. Okay, I'm waiting for answer for some questions. Look, first question for today's session, answer it very carefully. Answer it very carefully. What will be the correct answer? Long-term elastic modulus in terms of creep coefficient theta and 28-day characteristics and FCK is given by. So in the question you are given with, this data. So what will be the correct answer? What will be the correct answer for this? Please answer it very carefully. Now short-term Young's modulus of elasticity is, for concrete is 5000 under root FCK. Okay, this is short term. Now when the effect of creep is taken, what will be the Young's modulus of elasticity for long term? Okay, for long term, okay, the Young's modulus of elasticity is short term upon 1 plus theta. Theta is creep coefficient. So when you are taking the long term, you need to consider the effect of creep. Understood everyone? Now look very carefully. So this will be equal to 5000 5000 under root of f ck, 5000 under root f ck upon 1 plus theta. So what is the value of theta? What is the value of theta? Yes. What is the value of theta? The value of theta depends upon age of the loading. Okay. Age of the loading. 7 days, 28 days and 1 year. Okay. Understood? Okay. So the value is 2.2, 1.6 and 1.1. For 1 year it is 1.1. Clear everyone? So what is the correct answer? Option A is the correct answer. 5000 under root f ck 1 plus theta. Understood? Clear? Yes. So we'll move ahead with the next question. Answer the next question, guys. If sigma CBC is permissible compressive stress in flexure compression in service, the modular ratio is. What will be the correct answer? Now answer it very carefully, everyone. Is audio video clear? Now answer it, everyone. What will be the correct answer? Yes, very, very good. Yes, very good. Okay. Please make sure that from tomorrow your classes will be from 11 a.m. Okay. From tomorrow your classes will be from 11 a.m. and please mind it. Okay. These questions are specifically taken for your state PSC examination. Okay. If I would have taken these questions for GATE examination, the question level are different. Understood, everyone? Okay. Okay. The correct answer is, what is modular ratio? Now, if sigma CBC is permissible compressive stress in flexure compression, the modular ratio. So modular ratio is defined as 280 by 3 sigma CBC. 280 by 3 sigma CBC. Understood, everyone? Okay. So option A is the correct answer. Now we'll move ahead with the next question. The permissible shear stress in concrete depends upon. This is a very good question. So there are two concepts, the permissible shear stress and maximum shear stress in concrete. So both the concepts are different. हाँ, लेवल बढ़ाएंगे भाई, नेक्स्ट क्लास से लेवल बढ़ा देंगे, ये बेसिक क्वेश्चंस हैं, ठीक है. सो जो स्टेट सर्विसेज, the maximum state services have these type of question only. Okay, so your speed matters in state services, your speed matters. Okay, so from next time I'll little increase the toughness level of the questions. Now what is the correct answer? The permissible shear stress. Now look very carefully. What is the permissible shear stress? Permissible tau permissible. Okay, so the permissible shear stress in the concrete depends upon two factors, that is grade of concrete, and percentage steel, but the maximum shear stress of concrete depends only on grade of concrete. Please make sure that permissible shear stress depends upon two values, the grade of the concrete and percentage steel, but your maximum shear stress on concrete depends only on grade of steel, grade of concrete. Understood, everyone? So here you are asked with the permissible shear stress, hence option D is the correct answer. Option D is the correct answer. Understood, everyone? We'll move with the next question. Answer it very carefully. This is a very good question. Now this is a very good question. Most probably you'll able to Please put a star mark because most of the student will give the wrong answer for this question. Please read it very carefully. Now yield strength is 400 megapascal. Now if you have a steel of grade 400 megapascal, okay. Now look very carefully. None of the, yes. What is the value of maximum allowable tensile strength? Maximum allowable, so what is the allowable strength? What is the maximum allowable strength? Maximum allowable strength is maximum allowable strength. Now tensile strength have two values. Maximum allowable strength in axial tension. So what is the permissible value? What is the permissible value? 60% of yield stress. And for bending tension, maximum allowable strength in bending tension. So maximum allowable strength in bending tension. Okay, in bending tension. So this value is 66% of yield stress. 66% of yield stress. So it multiplied 60% of yield stress means 0.60 into 400. So you will get the value as 240. You will get the value as 240 Newton per mm square. So only this option is correct. Hence you will get the value as 240. Option A is the correct answer. Understood everyone? Clear? Now we'll move with the next question. Answer it very carefully, guys. Now the question is the minimum clear cover to the main steel bar in slab, beam, column, footing. So clear cover. Now the minimum clear cover to the main steel bar. Okay. What is the clear cover? To main steel bar, to slab, beam, then we have column, then we have footing. What will be the correct answer? These are standard value. So how much stress will you permit in the steel? That is 60% of yield stress. And how much, if let us suppose in steel bars, if there is bending tension, how much stress will you permit? Okay, that is 66% of yield stress. So what is the correct answer? What is the clear cover for slab, beam, column and footing? So for slab it is 15 mm. So what is the correct answer for this? Yes, very good. So for slab it is 15 mm. For beam it is 25 mm. For column it is 40 mm. And for footing it is 75 mm. So this much is the clear cover. This should be given to the slab, beam, column and footing. So 15, 25, 40 and 75 is option B. Option B is the correct answer. Understood everyone? Please make sure for flat slab, expert gaming, for flat slab it is 20 mm and for normal slab it is 15 mm. Now please make sure it is for flat slab. For flat slab it is of 20 mm. Understood everyone? Please don't confuse it. Clear everyone? Beam 25, column 40 and footing 50 mm. Understood? So please don't confuse about normal slab and flat slab. Only flat slab have the clear cover of 20 mm. Understood everyone? So that is why we have taken option B. Now moving with the next question. Answer it very carefully. The desired characteristic strength of a mix is, the characteristic strength of the mix is FCK is 20 Newton per mm square. Okay, this is given in the question. The standard deviation given is 4 Newton per mm square. Okay, 4 Newton per mm square. for 150 mm size of the concrete cube, and K value is constant 1.645. Okay, the average strength of the cube will be nearly. So this average strength is nothing but the target mean strength. So this is nothing but Fm is equal to FCK plus 1.65, or here we'll take the 1.65 and in place of 1.65 it is 1.645 into sigma. So this is 20 plus 1.645 into 4. Okay. So you can see very carefully, if I consider this value as 1.5 into 4 is nothing but 6, 20 plus 6 is 26. So you will get the value slightly greater than 26. Only one option is there which have the value slightly greater than 26. Hence option C is the correct answer. Understood everyone? So you, in the examination, you don't need to calculate each and every aspect. It is just an objective question. Okay. So consider this 1.645 as 1.5. So you will get the value as 6. So your answer is slightly more than 6. Hence you will get the option C is the correct answer. This is what is called aptitude. Okay. So in the examination where there is no calculator, you just need to apply your aptitude and reach to the answer. Clear everyone? We'll move ahead. We will move ahead with the next question. Answer it very carefully. This is a very simple question. Answer it. You'll get the answer. Very simple question. Okay. The value of creep coefficient of concrete at an age of 28 days loading is, now value of creep coefficient. We know that age of loading, it depends upon age of loading and the value of creep coefficient. So if 7 days, if you have applied the load in 7 days, the creep coefficient is more, 2.2. In 28 days, it is 1.6, and for 1 year, it is nothing but 1.1. So in the question you are asked about 28 days, the value is 1.6. Option B is the correct answer. Understood everyone? Clear? Option B is the correct answer. We'll move ahead with the next question. This is a good question. Please answer it very carefully. If no reinforcement is given in the RCC structure, after concreting, the concrete shrinks. Okay. So to consider the shrink, so what is the shrinkage strain in the concrete which is taken? So sometimes minimum reinforcement is provided, okay, to prevent the stresses due to shrinkage. So approximate value of shrinkage strain in concrete is, please answer. Yes, very good. 0.003. So correct option is option B. Okay. So shrinkage strain is taken as 0.003. So this is the correct answer. Option B is the correct answer. Understood everyone? We'll move ahead with the next question. Please answer this. The maximum compressive stress in concrete for design purpose is based on the partial safety factor of. So now in limit state method, we apply the factor of safety to material strength also and to the load also. So what is the partial safety factor for concrete? Partial safety factor for concrete. So now partial safety factor for concrete strength is taken as, we divide the strength by 1.5, and for steel, since steel is manufactured in industries, the partial safety factor is less. How much is the value? 1.15. Here you are asked with concrete, hence option B is the correct answer. Option B is the correct answer. We'll move ahead with the next question. Please answer it. This is a very good question. Please answer it. This is a good question. in the 4th amendment May 2013 of IS 456-2000, M60 grade has been shifted to. Now look, there are three type of concrete as per IS 456-2000. There are three type of concrete: ordinary concrete, standard concrete, ordinary concrete. Ordinary concrete is of M10, M15 and M20. Okay, ordinary concrete. Okay, then we have standard concrete. Standard concrete, so M25. Now look, earlier, what is the correct option? Now look very carefully. Now this is M60. Now, M60, M25 to M60. Then we have high strength concrete. Then we have high strength concrete. Look very carefully. Yes, very good. M65 to M100. Now look, earlier, so this is the amendment in 2013. Earlier, look very carefully, the standard, this M60 was in high strength concrete, but now this M60 has been shifted to standard concrete. Okay, now look, now in the 4th amendment May 2013 IS 456-2000, M60 grade has been shifted to. Earlier it was high strength concrete, but now it is shifted to ordinary concrete, standard concrete from high strength concrete. This option A is correct. High strength concrete from high strength standard concrete, standard concrete from ordinary concrete. No, this is wrong. Ordinary concrete from standard concrete. Option A is the correct answer. Clear? So this is the amendment on May 2013. Understood everyone? Option A is the correct answer. Clear? Understood. Now we'll move ahead. Now next question. Next question is this. Answer it. The partial factor of safety for steel as per IS 456-2000. This is a very simple question. Just now we have said that partial safety for steel is as per IS 456 1.15. Okay. Why the partial safety factor is less as compared to concrete? Because it is manufactured in industries. Hence, more quality control is taken care while manufacturing the steel. Hence, partial safety factor is less. So, what will be the correct answer? 1.15. Option A is the correct answer. Clear everyone? We'll move towards the next question. Answer it very carefully. The development length of each bar of 3 bars bundled together is increased by, okay, whenever what you have done is, you have 3 bars, okay, you have 3 bars, okay, these all are bundled, okay, or I'll show you the longitudinal axis. This is 1 bar, okay, this is 2 bar and 3 bars. These all are bundled, okay, these all are bundled. So when the 3 bars are overlapped and bundled together, okay, so development length are increased. How much it is increased? How much is increased? Answer it very carefully, guys. What is the correct answer? Very good. Now look very carefully. When 2 bars are bundled, now please note down, as per IS 456, when 2 bars are bundled, okay, the development length is increased by 10%. The development length is increased by 10%. Okay, when 3 bars are bundled, okay, when 3 bars are bundled, their development length increased by 20%. And when 4 bars are bundled, okay, when 4 bars are bundled, are clubbed together, okay, development length is increased by 33%. So since here 3 bars are bundled, your option B is correct. Option B is correct. Understood everyone? Yes. This is the correct answer. Okay. Now moving ahead with the next question. Answer it very carefully. loss of stress with time at constant strain in steel is called relaxation, ductility, creep or shrinkage. Look, these two bars are bundled. These two bars are bundled. Understood everyone? Overlapped. Now if we have third bar also above it, so this is the bundle of 3 bars. So the development length increased. What is the correct answer? Yes, this is very good. Creep is the correct answer. Okay. So continuous deformation over a period of time. Okay. Because of the sustained loading, because of this there is a loss of stress. Okay, with a constant strain. Okay, in steel it is called creep. Understood everyone? Option B is the correct answer. This is called creep. So creep initially increases with time, then it decreases. So initially we have elastic strain and then we have plastic strain. When you remove the load, okay, all the elastic strain is being recovered, but some of the plastic strain is left. Okay, that is permanent deformation. Clear? Option B is the correct answer. That is creep. Now answer the next question. What is the correct answer? No. Answered. Now please look very carefully. I'm really sorry. In the previous question, I'm really sorry here. I have taken the wrong answer. I'm really sorry. The here you are asked with the loss of stress. You are asked with the loss of stress. Creep is the continuous deformation over the period of time. I'm really sorry. Please, I'm really sorry. The correct answer is not creep. Now look very carefully. I'll explain you how. Now let us suppose we have a bar. We have a bar. Okay. And on this bar there is a continuous load if there is a continuous load P. So whenever you apply the load P, what will happen? There is a elastic deformation. Thus the moment you will apply this P load, there is a elastic deformation of dx. This dx is nothing but elastic deformation. But over the period of time, because of this continuous load, what will happen? In this section you will have this, over the period of time, this plastic deformation, and it increases as the time passes. This dy is known as plastic deformation. So if we plot the graph of stress, so what will happen? Initially when you apply the P load, there is this much is the strain, but after a period of time this much is the strain. So this is nothing but, this strain is elastic deformation, elastic strain. And you can see very carefully, this is nothing but a plastic strain. These strain are known as creep. Understood everyone? When you apply the load, when you have released the load, after removing the load, what will happen? This much of the strain is being recovered. Okay, and then afterward few of the strain is also recovered. So this yellow curve indicates of unloading. So this much is nothing but elastic recovery. This much is known as elastic recovery, and you can see this much is known as plastic recovery. And this much strain is not recovered. This is known as permanent deformation. Understood everyone? So it is a time dependent process. As the time increases, the strain also increases. Which type of strain? This is permanent strain, plastic deformation strain. Understood? So this is nothing but the creep. This deformation is nothing but the creep. But whenever But whenever, what will happen, because of this creep, their stress is also generated. But whenever the strain recovered, whenever when you remove the load, this elastic strain is recovered. So whenever the elastic strain is recovered, there is a loss of stress also. That is known as relaxation. The loss of stress is known as relaxation. So I misunderstood it. The loss of stress is known as relaxation. Please mind it. The loss of stress is known as relaxation. Understood? Option A is the correct answer. Whenever you find loss of stress, you'll get the answer as relaxation. Understood, everyone? So continuous deformation over the period of time is known as creep. Continuous deformation over the period of time is known as creep. Okay, but during the creep, if there is some loss of the stress, so that is known as relaxation. And what is ductility? Ductility is nothing but ability of material to deform into wires. Okay, or technically we say that if material have more than 5% post elastic strain. Post elastic strain means plastic strain. Then only you will be able to deform them into wire. Okay, that is ductility. Understood, everyone? So relaxation is the correct answer. Now moving ahead with the next question, please answer it very carefully. Why is minimum tension steel is provided in a reinforced concrete? This is a very good question. Every time you will see in beam also we will provide the minimum reinforcement. In slab also we will provide the minimum reinforcement. In column also we will provide the minimum reinforcement. So why this minimum reinforcement, tension reinforcement is provided in reinforced concrete beam? To arrest attack width, okay, to control excessive deflection, to prevent hairline crack formation, to prevent sudden failure. Now look very carefully. Let us suppose I have this beam, and I have this beam. Whenever I casted this beam, okay, when I casted this beam, there is no reinforcement because the load is very less. The load is within the permissible limit. But what happens is this beam is within this fixed support. This beam is within the fixed support. So what happens is, after the casting of the beam, evaporation of the water, which is pore water, that is gel water, takes place. After the evaporation of that gel water, what will happen? Shrinkage of the beam will take place. Shrinkage of the concrete will take place. Because you have arrested this shrinkage, what will happen? Resistance of the movement is known as strain. Whenever you resist the strain, stresses are developed. So that is why these stresses are developed. Because of these stresses, what will happen? The hairline cracks are developed. Small cracks are developed on the surface. These are known as hairline cracks. Okay, to prevent these hairline cracks, minimum reinforcement is always provided. Minimum reinforcement is always provided. Understood, everyone? Clear, everyone? So what will be the correct answer? Why in RCC always minimum reinforcements are provided? To prevent hairline crack formation. Option C is the correct. Please put a star mark on this. And it is not a sudden failure, it is a gradual failure, because evaporation of the gel water from the surface takes place. It takes time. It is not a sudden process. Understood, everyone? It is a gradual process. And because of this, there is a hairline crack that are developed on the surface. To prevent this, we always provide minimum reinforcement. Understood, everyone? Understood? Shall we move ahead? Okay, we'll move ahead with the next question. Please answer it very carefully. What is the maximum permissible acid soluble chloride content for reinforced concrete? This is a very good question. What is the correct answer? Now this is a very good question. You will get the answer of this question. You will get the answer of this question on table number 7 of IS 456. What is the maximum permissible acid soluble chloride content? Because more will be the chloride content, it will lead to the corrosion of the reinforcement. So whenever you are using the water to make the concrete, for which reinforced concrete, so what is the maximum permissible acid soluble chloride? Maximum permissible chloride content is 0.6 kg per meter cube. 0.6 kg per meter cube. So option B is the correct. Please put a star mark on this. This was asked in one of the examination. Okay. Now note down one more thing. If the concrete does not have any embedded metal, if you are concreting for plain cement concrete, there is no metal inside the concrete does not contain any embedded metal, does not contain any embedded metal. So what is the maximum value of chloride content? That is nothing but 3 kg per meter cube. 3 kg per meter cube. This is the maximum value. Understood? So these 3 values you need to know. I hope it is clear. Shall I move ahead? No. Next question. Now in the previous question we have seen minimum tension reinforcement. Do you know what the minimum tension reinforcement area? So this is nothing but AST upon AST, minimum tension reinforcement upon B into D is equals to 0.87 upon 0.87 upon. Is this correct? Is this correct or wrong? Is this correct or no? This is 0.85 upon Fi. Very, very good. Very, very good. AST upon BD, minimum tension reinforcement. Minimum tension reinforcement is this is the, yes, very, very good. Yes, 0.85 upon F5. Very, very good, everyone. Now moving ahead, please answer this question. In an under reinforced section, okay, in an under reinforced section, what is the case? If let us suppose this is for balance section, this AST is for balance section, okay. This AST is for balanced section. Now answer it very carefully. If at balance section, what will happen? Okay, this will reach to the permissible value sigma CBC. This will reach to its permissible value sigma ST upon M. Okay, but if it is a under reinforced section, so this means that the reinforcement given is less than the balance section. So what will happen? Now look very carefully. You can see the yellow one. The stress in the concrete will be less than, stress in the concrete is less than sigma CBC, but stress in the steel reaches to its permissible value sigma ST. So failure of the steel takes place before the concrete. So concrete is not fully stressed up to permissible stress. Yes, reinforcement is not fully stressed up to permissible limit. Option B is wrong. Option B is wrong. Either or B is also wrong. So what will be the correct answer? Option A will be the correct answer. Okay. Now both is also not the correct answer. Option A is the correct answer. So this is a very simple question. Understood, everyone? We'll move ahead with the next question. Please answer it very carefully. The anchorage value of hook is assumed 4 times the diameter of the bar. If the angle of bend is, now this is a good question. Anchorage value, please answer it very carefully. The anchorage value of hook is assumed 4 times the diameter of the bar. Okay, 4 times of diameter of the bar. Okay, the anchorage value. So the angle of the bend is, what will be the correct answer? Very, very good. So if you bend the reinforcement 45 degree, so you need to give the extra anchorage length, that is 4.5. So for 90 degree it is 8.5. For 135 degree it is 12.5, and for 180 degree U type hook, okay, or bend, this U type, what will be the correct answer? 4, 8.5, 12.5, and what is the value for 180 degree? What is the value for 180 degree? Can you answer it? 16.5. Very, very good, everyone. 16.5. So here you have asked with 45 degree bend. Option C is the correct answer. Option C is the correct answer. Very, very good, everyone. We'll move ahead with the next question. Please answer it. For RCC braced frames, maximum redistribution of moment allowed is, this is a very good question. For RC braced frame, so last 4-5 question. What is the correct answer? For RC braced frame, the maximum redistribution of moment allowed is, very, very good. So you can only redistribute the moment of 30% of the maximum value. You will not allowed to redistribute the moment more than 30% of the maximum value. Hence, you will get the maximum value as 30%. Option A is the correct answer. Option A is the correct answer. Understood, everyone? Now we'll move ahead with the next question. Please answer it. Ratio of modulus of elasticity of two different material. Now, ratio of modulus of elasticity of concrete or modulus of elasticity of steel to modulus of elasticity of concrete. Let us suppose these are the two. Factor of safety, Poisson ratio. Poisson ratio is lateral strain to longitudinal strain. Okay. Yield stress upon permissible stress is factor of safety. Stress ratio, stress of the steel to the stress of the concrete. Here you are taken the ratio of modulus of elasticity. Hence option D is the correct answer. Understood, everyone? Option D. Young's modulus of steel to the Young's modulus of concrete. This is nothing but modular ratio. Clear, everyone? This is modular ratio M. I hope you have understood this point. Option. Factor of safety is not the correct answer. Factor of safety is defined as yield stress to permissible stress. Yes or no? Yield stress to permissible stress. Yield stress to permissible stress. This is factor of safety. Understood, everyone? And we are talking about the ratio of modulus of elasticity. Hence option D. Please answer it. If you have a curved beam, curved RCC beam, you have this curved RCC beam, okay. A beam curved in plan is designed for bending moment and shear, bending moment and torsion, okay, and it is a beam. Understood? It is a beam, transverse. So transverse load is acting upon it. Whenever transverse load is acting upon the beam, bending moment and shear force automatically developed. Understood? So apart from it, for the curved beam, torsion also developed in the curved beam. So what will be the correct answer? Apart from bending moment, shear force, torsion is also developed in the. Answer it. What will be the correct answer? So for curved beam, always we designed for bending moment, shear force, and we always designed for bending moment, shear force, and torsion. Bending moment, shear force, and torsion. So what will be the correct answer? Option D is the correct answer. Understood? Option D is the correct answer. So curved beams are designed for bending moment, shear force, and torsion. Understood, everyone? Clear? Now next question. The pH value, this is a very good, this is, please put a star mark on this, very good and very important question. The pH value of water for quality concrete shall not be less than. So 3 factors are you need to remember: pH, organic content, inorganic content. These 3 you need to remember: organic content, inorganic content and chloride content. Very, very good. The correct answer is, please answer it very carefully. The pH value of water for quality concrete shall not be less than. So for concrete manufacturing, you need to see that the pH of water shall be in the range of pH of water for which you are making the concrete is in the range of 6 to 8.5. 6 to 8.5. So shall not be less than 6. Shall not be less than 6. So here you need to remember some values also. Organic matter, organic solids. Okay? Organic solids. Then you have inorganic solids, sulfates, and then we have chlorides. Chlorides we have 2 value for RCC and for PCC. Okay, sulfate, organic content and inorganic. So these value you need to remember. So please remember these values. Organic content is 200 milligram per liter, inorganic content is 3000 milligram per liter, sulfates is 400 milligram per liter, and for chlorides is, for chloride it is 500 milligram per liter. Shall not be more than, these are the maximum values. Okay, 2000 milligram per liter. Okay, for PCC. Sulfate is 400 milligram per liter. Organic content is 200 milligram, should not be more than 200 milligram per liter. So this you need to remember. Understood? And inorganic is nothing but 3000 milligram per liter. 3000 milligram per liter. Understood everyone? Okay. So here you have asked with pH. pH is 6 to 8.5. So these you need to remember. Please note down, if you have note down in your copy. Please note down this value. Written everyone? Shall I move ahead? pH is 6 to 8.5. Yes, very good. We'll move with the next question and the last question for today's session. Okay. Now please remember, now from tomorrow your class will start from 11 AM. Now from tomorrow your class will start from 11 AM and roughly around 200 question I'll cover more. Okay, in RCC 200 more question I'll cover in RCC, so that your all concepts will be covered. Understood everyone? Okay, we'll move with the next question. And the last question for today's session, please answer it very carefully. Please answer it. Consider the following statement as regard to rheology of concrete. Rheology you must have studied in fluid mechanics also. Rheology of concrete. It deals with strength of concrete. It deals with deformation in concrete. Yes, rheology deals with the how the material deform under the action of load. So this is good, this is right. It also deals with the strength of the concrete. Rheology also consider with the strength of the material. Okay, it is the study of deformation and flow of concrete. Yes, very good. Deformation and flow of concrete. Yes, it deals with the rate of shear and shear. Yes, shear strain and the shear stress. Rate of shear strain and shear stress in the concrete. Yes, this is also correct. Hence all the options are correct. Option A is the correct answer. Option A is the correct answer. So rheology deals with, हाँ ये महाट्रांसको के लिए भी रिवीजन है दोस्त. दिस इज द रिवीजन फॉर महाट्रांसको ऑल्सो. क्लियर है एवरीवन, है ना? So I have covered, I'll take all the concepts of RCC so that you will get benefited in all the examination. So this is the correct answer. Rheology deals with the deformation. Okay, deformation I'll try to cover the physics and chemistry part also. Look very carefully. Rheology deals with the how on applying the load, the deformation of the material take place, as well as how on applying the shear stress, the shear deformation takes place. So these two are also correct. 3 and 4 is also correct, as well as it deals with the deformation in the concrete, it deals with the strength of the concrete. Hence all the options are correct. Option A, this is the question from engineering services examination. I hope it is clear. This is it for today's session, guys. Okay, and you'll get the PDF on Telegram channel, Concept Seekho SSC. On Telegram, you just search ASM Live, ASM without space LIVE, ASM Live. On Telegram, just search ASM Live. You'll get the PDF of this annotated PDF on this Telegram channel. Understood, everyone? So from tomorrow onwards, I'll take the session from 11 AM. Please be prepared. Most probably for 1.5 hours, we'll take the session. Understood, everyone? Yes, in the last moment, this session I have created in just last moment, but from tomorrow, we'll take the session from 11 AM in the morning. 11 AM in the morning. Okay. So thank you so much, guys. Okay, everyone. Bye-bye, everyone. Okay. Bye-bye.